All right, well, this video is for section 3.4. The first part, we're going to do this in two parts. So we're going to go up through problem 14 in section 3.4 in this video. And then in the second video, we'll finish off the problems from 15 up to 26. And then that'll be it. That's the last assignment for the course. Okay. So first off, in section 3.3, we talked about this property of logarithms that says if you take the log of something being raised to a power, then that power comes down in front as a coefficient, and we talked about why that is. So today, in solving these equations, we're going to talk about two more properties of logarithms. One says that if you take the logarithm of two things being multiplied, you can add their logarithms. And the other says if you take the logarithm of two things being divided, you can subtract their logarithms. We're mostly going to be going in this direction. We're going to take something that looks like this and turn it into something that looks like that. The other thing that I want to say about this is that these all have to do with the fact that a logarithm is an exponent, right? If you go back to your rules for exponents, when you raise a power to a power, you multiply the exponents. If you multiply two things with the same base, you add their exponents. If you divide two things with the same base, you subtract their exponents. So let's go through this symbolically, okay? So let's say we've got log to the base b of m. We'll call that some number x. And so then b to the x is equal to m. Then we'll say log to the base b of n is some number y. So then b to the y power should be equal to n. Okay. Now, we're interested in m times n. So m, let's see here, let's make that neater. M times n is b to the x times b to the y. And here's where we add the exponents. That makes b to the x plus y. Now the question of what is log to the base b of m times n? This is asking the question, what power do you raise b to get m times n? There it is right there, x plus y. And what is x again? Log to the base b of m. And what's y? Log to the base b of n. So there it is. If you take the logarithm of two things being multiplied, you can add their logarithms. The second piece is m divided by n, and that's b to the x divided by b to the y. There's your rules for exponents, b to the x minus y. And then the question of what is the logarithm of m divided by n? Well, what power do you raise b to get m divided by n? There it is right there, x minus y. And that's log to the base b of m minus log to the base b of n. Okay, so there's the reason for why these properties are true. Now let's look at some problems where we're going to use these properties to solve them. And of course, don't forget the fundamental definition of a logarithm says that if log to the base b of m is equal to x, then that means that b to the x power is equal to m. And these two, this little symbol right here means that these two statements are equivalent. Okay. All right. So let's look at some of the problems from section 3.4. These are on page 173. And let's see. We'll start with problem 2. And that says log to the base 4 of x plus log to the base 4 of 5 equals 1. Okay. So we're going to use this property of logarithms right here, and we're going to rewrite this as log to the base 4 of 5 times x. All right? Then we're going to use this right here and say, well, that must mean that 4 to the first power is equal to 5x. Divide on both sides by 5, and x is 4/5. If you want to call it 0.8, that's fine as well. All right, well, there's problem 2. Let's take a look at problem 4. Problem 4 says log to the base 5 of x equals 2 plus log to the base 5 of 3. And notice that these bases are always the same, and they have to be the same for these to be true. If these bases are not the same, then those properties won't be true. All right. So let's see. I'm going to collect these logs on the same side. I'm going to subtract this log to the base 5 of 3 on both sides. These cancel out. Over here, we get log to the base 5 of x minus log to the base 5 of 3. So now we're going to use this property right here and rewrite this log to the base 5 of x divided by 3 equals 2. Then I'm going to use this process right here and say 5 squared equals x over 3. So 25 is x over 3. Multiply on both sides by 3. And x is equal to 75. Okay, so there's some beginning problems, some kind of simple problems to get us started on these concepts. Let's start working our way into the more complex problems. Let's see here. Problem 6. Let's see here. So log to the base 6 of x plus log to the base 6 of x minus 5 equal to 1. Okay, so these logarithms are being added together, so that means we're going to rewrite them as multiplication. X times x minus 5. And now we'll restate this using exponents. 6 to the first power is x times x minus 5. And now this is just a quadratic equation. X squared minus 5x minus 6. And this is factorable. You can run it through the quadratic formula if you want to. It also factors, and we would get x equals 6 or x equals -1. And that's fine. So if you read through the textbook, I go into this sort of explanation about how most textbooks and instructors reject negative answers for logarithms, because if you take the log of -1, you will, let's see, what happens if I do log of -1 here? Yeah, you get, it's kind of hard to notice, but let me show you what happens here. If you take log of -1, you can kind of see at the very last character there, you can see this I right there. Okay, that's a complex number, and so just the same way that people frequently, say no solution if you've got a square root of a negative number or something like that. Same thing happens here. If you take the logarithm of a negative number, you get a complex valued answer. I don't have a problem with that, and I accept these negative answers. Most textbooks and instructors reject those negative answers, but don't really give any explanation for why. Okay, so there's problem 6. Let's look at problem 8. Let's see, problem 8 says, let me take it straight from the textbook here. Log x minus 1 minus the log of x is -0.5. Okay, so this is a subtraction of logarithms, so we're going to use this property right here, and we're going to say log of x minus 1 over x is equal to -0.5. Now notice that we don't have a base for this problem. That means this is base 10. Log to the base 10. So that means if we want to rewrite this, we'll say 10 to to the negative 0.5 power equals x minus 1 over x. So let's get a good approximation for that 10 to the negative 0.5 power. Let's see here. Okay, so 10 to the negative 0.5 there is going to be about 0.3162. We'll call it 0.3162. All right, and then we'll multiply on both sides by x. So x minus 1 equals 0.3162x. Let's see here. I'm going to add this one over here and subtract this 0.3162x. So those cancel out, those cancel out. There's a positive 1. So right here, don't forget your basic algebra. This is 1x. And this is 0.3162x. So we got to do 1 minus 0.3162. And that'll give us 0.6838x. And then we got to divide on both sides by 0.6838. And so 1 divided by 0.6838 tells us x is approximately equal to 1.462. Okay. So those problems were a little bit more involved than the first two that we talked about. Well, let's look at a couple more. Let's see here. Problem 12. Problem 12 says log to the base 2 of x minus log to the base 2 of x plus 3 equals 2. All right, so let's see. This is a subtraction of logarithms. So we're going to rewrite this as log to the base 2 of x over x plus 3. And then that means 2 squared equals x over x plus 3. So 4 is x over x plus 3. Now we need to multiply on both sides by x plus 3 to clear out that denominator. Over here we get 4x plus 12. Let's see, move the 4x over here. And again, that's a 1 minus 4 is negative 3x. And then we'll divide on both sides by negative 3. So x is equal to negative 4. All right. So that's problem 12. Let's see, I'm going to need some more space here, so I'll erase this one. And let's look at problem 14. Problem 14. Log to the base 4 of u plus log to the base 4 of u plus 1 equals 1. Okay, so this is the sum of two logarithms, so we'll rewrite it as log to the base 4 of u times u plus 1 equals 1. Now we'll say 4 to the first power must equal u times u plus 1. So 4 is u squared plus u. And so then we'll move the 4 over there. So 0 is going to be u squared plus u minus 4. Let's run it through the quadratic formula here. All right, let's see here. 1, 1, negative 4. And so we get u is approximately equal to 1.562 or negative 2 0.562. Okay, so that's it for this video. Your assignment is just to do the odd problems up to problem 13, and then I'll come back and make another video for the second half of section 3.4, and that'll be our last assignment for the term. So we'll see you then.